Charge me up like electricity. Jumpstart my heart with your love. There's an energy when you hold me, when you touch me.
Has it ever happened to you that it's the middle of the summer and the air conditioning in your house breaks? What is the first thing you do? That's what I thought. You go to Walmart and get materials to make a solenoid engine.
In the autumn of 1820, Andre Ampere was studying the connection between current and magnetic fields. So he experimented with two wires. When he ran current through those two wires in the same direction, the wires attracted to each other. Whenever he ran current through those two wires in opposite directions, those two wires repelled each other. By studying these wires, he was able to discover one of the most fundamental laws of electromagnetism, Ampere's law.
And this Ampere's law states that for any closed path, the sum of the length elements times the magnetic field in the same direction as those length elements is equals to the permeability times the electric current enclosed in that loop. And this magnetic field we are talking about is generated by the enclosed electric current. And a way we can visualize the direction of this magnetic field is by using the right-hand rule or the right-hand grip.
So using the right-hand rule, we can see the direction of the magnetic fields. So whenever current is going through a wire going in this direction, upwards, the electromagnetic fields follows the direction of your curled fingers. So in the case where it's going up, the field is going this way. And in the case where it's going down, the field is going this way. So a solenoid is a wire that's been wrapped around like a coil. Whenever you use your right-hand rule, you can imagine the coil being wrapped around in this direction. So whenever the current's being passed around in this direction, the electromagnetic field is exiting through the North Pole, wrapping back around and going into the South Pole. Likewise, when it's flipped upside down and the coil is being wrapped this way, the current is going this way, and the electromagnetic field is exiting through the North Pole, downwards, up, and then back into the South Pole.
So Ampere's law is used in many everyday applications. For example, Ampere's law is used in car starters and railroads where they act as an electric switch. They're also used as fluid flow in dishwashing machines and washers. They also have other applications such as acting as the fan in your computer to stop it from overheating.
Based on Ampere's law, we decided to build a solenoid engine to use it as a fan in order to solve a real-life problem. First of all, we designed the platform that holds everything together using SolidWorks, and then we got it 3D printed on campus. The next step was to build a coil strong enough to pull an iron rod towards it. Once we made sure that it had the necessary strength, we put the pieces together and the result was successful. These sparks mean the circuit closes when the axle is at a certain angle, and the current flows through the coil, creating a magnetic field that makes our engine work.